Hey everyone, welcome to the 6th lesson of Unit 2 of Math 2. Last time we talked about the different forms of a quadratic function. One of those was the vertex form. Now you should already be pretty comfortable with the vertex form and how to graph a parabola from that vertex form. Well, we introduced the idea of standard form and factored form, and basically how to convert different forms into standard form. So if you remember, we talked about expanding, multiplying binomials, and then simplifying it all so it's in a standard polynomial form. Well, today we're going to take the standard form and we're going to graph from that form, and we should be able to identify some key features that are given to us in standard form that helps us graph the parabola relatively quickly, okay? So again, our goal today is to be able to graph a parabola that whose function is written in standard form, okay? I can determine the vertex of a parabola from standard form, and if you can determine the vertex, you can graph a parabola. All right, so remember, first of all, that standard form is y equals ax squared plus bx plus c, where a, we know what a is represents the slope pattern. We're going to discover a little bit today about what b does and what c does. So in order to graph a parabola, we need to get this screen out of the way so you can see what I wrote. We need two things, just like always. In order to graph a parabola, you need two things. You need the vertex and you need your slope pattern. Okay, just like you would with vertex form, you need your vertex and your slope pattern, no matter what form you're given. Okay, the question is, how do I determine these two things when I'm talking about standard form? Well, the slope pattern is exactly what it would be in vertex form. Remember vertex form, I'll go ahead and write this down here. Vertex form is y equals a times x minus h squared plus k. Well, the a value represents your slope pattern in the same way that the a value in standard form also represents your slope pattern. So there's nothing different about that. That's nice. If a is positive, it opens up. If a is negative, it opens down, and then it follows the 1 over 1, 4 over 2, 9 over 3 pattern, and then you multiply that by the a value. So that's nice. The question, though, is what is the vertex? How do I figure out the vertex from standard form? Okay. Now we know how to find the vertex in vertex form. Remember, it's just h and k. But in standard form, we got to do a little bit of work to determine the vertex. Okay. Remember, the vertex is made up of two parts. There's an x part and a y part, or we label them in vertex form, we label them as h comma k. Okay. Well, another way to say that is that the vertex is made up of the axis of symmetry and then the maximum or the minimum value of that parabola, whatever it is. Okay. So if I were to just look at a quick parabola here, let's say this is my parabola that I'm graphing. Well, the vertex we see right here, the vertex in this case is 3, 1, right? We go right 3 and up 1. Well, it's made up of two parts again. It's made up of our axis of symmetry and either our max or min value. So we notice that the axis of symmetry is x equals 3, right? X equals 3. So we can see that the vertex has an x value that's the same as the axis of symmetry. And then the maximum or the minimum value, well, this is a minimum. This is the lowest part of the parabola. The minimum value is 1, right? So we would say the minimum value is y equals 1. And so we can see that the vertex is composed of these two things. Okay, so we just need to know how to find the axis of symmetry then and the max or min value. Okay. Oh, I guess I have another example here so we can see it. A little prettier graph, I guess. In this case, we can see that the vertex is going to be 1 comma negative 5. Okay. And we can see that the axis of symmetry is x equals 1. X equals 1. And then we can see that, again, this produces a minimum value of what? 2, 4, 5. It produces a minimum value of y equals negative 5. And again, we can see that our vertex is made up of our axis of symmetry and either our minimum or our maximum values. Okay? So let's talk about the axis of symmetry. How could I find the axis of symmetry? Okay? When a quadratic is written in standard form, you know, the y equals ax squared plus bx plus c, the thing we just wrote down a minute ago, then the formula to find the axis of symmetry is x equals negative b over 2a. If you can identify your a value, your b value, and your c value, you can just take those values and plug them into this formula to find your axis of symmetry. Okay? So the example that I'm going to give you is this. I want you to determine the axis of symmetry of each of the following two. Y equals 3x squared minus 12x plus 4, and then y equals negative 1/2 x squared minus 5x minus 7. So let's go ahead and do that off to the side here in my notebook. Remember, when we're taking notes, this is an example. So it should go on the right-hand side of your notes. Okay, clear this up. All right. So we've got y equals 3x squared minus 12x plus 4. And our job is to figure out the axis of symmetry. Well, the first thing we have to do is identify our a value, our b value, and our c value. If you can tell me what these three things are, then it's as simple as plugging into the formula. Remember, the a value is the number in front of the x squared. So the a value here is 3. The b value is the number in front of the x, so we can see that that's negative 12. And then the c value is the constant at the end. And just in case you forgot, right, you should have written this down, but standard form is ax squared plus bx plus c. Remember, when we write standard form, we write the highest exponent first, and then it decreases from there. And so if we have it in standard form, we can see our a value really easily. A is just the number in front. A is 3. B is negative 12, and then c is 4. Okay? So we have those three things identified. All we have to do to figure out the axis of symmetry is to plug those in to the formula negative b over 2a. And we will discover more and more as time goes on where this formula comes from. But for right now, we're just going to use it. So x equals negative b over 2a. Well, that means that x equals negative, parentheses, something, over 2, parentheses, something. And our job is to fill in those unknown values. What is b? Well, b is negative 12. So we're going to put negative 12 in the parentheses. I always substitute by putting parentheses around the number I'm substituting. That way I don't mess up on my signs or my operations or anything like that. What is the a value? The a value is 3. So we put that there. B is negative 12. A is 3. So we say negative b over 2a. And then we go ahead and simplify this. Well, simplifying the top, what is negative 12? Or what's negative 1 times negative 12? Well, that would be positive 12. And what is 2 times 3? Well, 2 times 3 is 6. And then we can simplify that a little bit. We can say x equals 2. So our axis of symmetry is x equals 2. So we're actually pretty far along the way of being able to graph our parabola now because we know the line, the axis of symmetry, based on this formula. Okay, so that was number 1. Let's go ahead and take a look at number 2 now. Number 2, the tricky thing about number 2 is that there's fractions involved. Now, don't let that overwhelm you. It's okay. We will work through this. Okay? So the first thing we want to do is identify our a value, our b value, and our c value. So in this case, a is negative 1/2, b is negative 5, and c is negative 7. Okay? Then we'll just take those values and plug it into our axis of symmetry formula. Remember, that's x equals negative b over 2a. And then we plug that in. X equals negative 5 over 2 times negative 1/2. Okay? Now, I'm not trying to be too complicated here. This isn't too bad. What is negative 5? That would be positive 5. And what is 2 times negative 1/2? In other words, if I take 2 halves, what do I get? I get a whole. If you don't like that, we could say, what's 1/2 of 2? Well, 1/2 of 2 is 1. If you don't like that, we could say, let's just multiply them. 2 times negative 1/2. How do I multiply fractions? I have to put the 2 over 1, and then I multiply straight across. That would be negative 2 over 2, which is negative 1. Okay? But the bottom line is I have 1/2 of 2. 1/2 of 2 is 1, and then we have a negative times a positive, which is a negative. That then simplifies to negative 5 as my axis of symmetry. So that's how you find an axis of symmetry. Okay? X equals negative b over 2a. And I walk through it here so you can see it in a cleaner form, I guess. But regardless, we get the same answers, so we're good to go. Okay? Now, let's go on to the next thing, because now that we have our axis of symmetry, we can use that to find the vertex. Well, how do we do that? Remember, the vertex is composed of the axis of symmetry and either the maximum or the minimum value. Since I already have the axis of symmetry, then I need to only find the maximum or minimum value. Well, how do we do this? We simply, in order to find the max or min, we have to substitute, and if I could spell right, substitute the axis of symmetry back into the function. And you'll see what I mean by that. Let's go ahead and take a look at, I believe these are the same examples that we just dealt with, yes? The 3x squared minus 12x plus 4, okay? So this is my axis of symmetry. Now I need to find either my maximum value or my minimum value. What's it say to do? It says to substitute the axis of symmetry back into the function. So we're going to take this function, the y equals 3x squared minus 12x plus 4, and we're going to replace the x value with 2. And so we end up with y equals 3, and now we're going to substitute, so we're going to put parentheses around this, 2 squared minus 12 times 2 plus 4. Okay? And then all we have to do from here is simplify that expression. Remember, order of operations, we have to do parentheses first. Well, technically, there's nothing inside the parenthesis to do. So there's no parentheses in a sense. It's just helping us identify what it is, what operations we're doing. So there's no parentheses to do specifically. Now we move on to exponents. Well, do we have exponents? Yes, we do. We have a 2 right here. So what is it we're squaring? We're squaring the 2. We're not squaring the 3 and the 2. So we don't want to multiply the 3 and the 2 first. We need to square the 2. 2 squared is 4. So I'm going to go ahead and write that down. 2 squared is 4. And then we'll carry everything else down as we go along. Then from there, we got y equals. Now we're done with exponents, so we go to multiplication and division. So we have 3 times 4 is multiplication. That's 12. And negative 12 times 2 is negative 24. And then from here, we add and subtract. So we end up with y equals, well, 12 minus 24 is negative 12, plus 4 is negative 8. So we can see that our maximum value or our minimum value, depending on which way the parabola is opening, is going to be negative 8. Well, because we have an x value of 2 and a y value of negative 8, we can conclude that our vertex is 2, negative 8. Okay? So we can see that finding the vertex from standard form is a little bit more difficult, because if it's in vertex form, it's already given to us. It gives us the vertex by just looking at the equation. But when we're talking about standard form, we have a lot more work to do. We have to plug into the formula to find the axis of symmetry, and then we have to take the result of the axis of symmetry and plug it into our equation to figure out the y value, the max or min, and then we can make up the vertex from the x and the y value. Okay? So let's go ahead and take a look at the second one here, where we have y equals negative 1/2 x squared minus 5x minus 7. Well, remember our axis of symmetry was negative 5. So to find the max or min value, we need to plug that negative 5 in. So it'll be negative 1/2 times negative 5 squared minus 5 times negative 5 minus 7. Order of operations, parentheses first. There isn't really any parentheses to do, so we move on to the exponents. So negative 5 squared. Well, what's negative 5 squared? Negative 5 times negative 5 is 25. And then we'll carry everything else down and simplify as we go. Well, now we do our multiplication. What is negative 1/2 times 25? Well, I know that it's a negative. What's 1/2 times 25? Well, I'll do that work over here. 1/2 times 25. Remember, I put it over 1. So we get 25 on top and 2 on the bottom. Okay. Now you could put that in decimal form. If you have a calculator, you probably would. That would be 12.5. But I'm going to leave it like this because I think it's a good idea to get the practice for fractions that some of us so desperately need. Then negative 5 times negative 5 is positive 25, and then minus 7. Well, how do I add these now that I have a fraction? Well, I've got to make these fractions, and I need to find a common denominator. So I'm going to put this over 1 and put this over 1, and I need a common denominator. Since this guy is 2, I want to make these guys 2. So I'm going to go ahead and multiply this by 2 over 2. And then this one as well, 2 over 2. That will give me a common denominator. So I end up with y equals negative 25 over 2 plus, well, 2 times 25 is 50. And then 2 times 1 is 2. Minus 7 times 2 is 14. And then 1 times 2 is 2. So now that I have common denominators, I can put all these together. So negative 25 plus 50 is positive 25, minus 14 is positive 11, and that's over 2. And so we can say now that our vertex is going to be negative 5, comma, 11 over 2. Or if you put it in decimal form, it would be negative 5, comma, 5.5. 11 over 2 is 5.5. And so that is our vertex, either one of those. Okay. The reason we might want to put it in decimal form is because when we go to graph it, we can plot that a little bit easier. Okay. Let me double check to make sure my work is right. I did get 2 comma negative 8 on that first one, so that's good. The second one, as I go through this work, I get 11 over 2, so my vertex is going to be negative 5, comma 5.5. All right. So that is how you find the vertex of a parabola if you are given standard form. Okay. So let's go ahead and do one last problem that kind of puts it all together. If you can graph a parabola from standard form, that means you've got it. If you can graph this parabola and identify all the pieces of it, you have nailed pretty much everything that we've done so far this year. Okay? So let's go ahead and go on to that. We've got j of x. Now don't get too worried. I know that we see these funky letters here. We got j of x equals negative 2x squared minus 12x minus 10. Well, j of x is just another way of saying y, right? It's just the name of the function, j. But it's the output value, so we call it y. So don't get stressed out by that. It just means y. Now, as I go through this process, I'm looking for the axis of symmetry, the max or min, the vertex, and then to graph the parabola. Because if you have the axis of symmetry and the max or min, you have the vertex. And if you have the vertex and the slope pattern, then you can graph the parabola. And then once you graph the parabola, you can identify all of these things down here, okay? So let's go ahead and find the axis of symmetry. First bit of work, axis of symmetry, remember, is x equals negative b over 2a. So we need to identify a, b, and c. So a is, remember, the first thing, the first letter, or the first coefficient there, it's negative 2. B is the second coefficient, negative 12. And c is the constant at the end, negative 10. Now that I know those, I can just plug those in. I end up with x equals negative 12 over 2 times negative 2. And then from here, we just simplify. Negative 12 is positive 12. And 2 times negative 2 is negative 4. So that simplifies to x equals negative 3. So that is our answer for part A. Our axis of symmetry is negative 3. Okay. Then we want to find, let's see, we're going to say that that is A. I'm going to put A here. Okay. So I'll put a little box around that to know that that work is done there. Okay. Then we'll go on to B. B says find the maximum or the minimum? Well, first of all, what do we know? We know that this parabola opens down because the a value is negative. So we know since this parabola opens down, what's going to happen? Am I going to produce a maximum or a minimum? Well, because it opens down, that is producing a maximum. Now, I wasn't necessarily asking whether it produced a max or a min. What I want to do is find out what that value is. So remember, to find that value, we take the x value that we just figured out from the axis of symmetry, and we plug it in to our original equation. So we're going to take -3 and plug it in here. So that'll say y equals -2 times -3 squared minus 12 times -3 minus 10. Order of operations, we do our exponents before anything else there. So we got -2 times 9, and then carry everything else down. Then we'll do our multiplication. So we end up with y equals -18 plus 36 minus 10. And then simplifying that from there, -18 plus 36 is +18, minus 10 is -8. So our maximum value is y equals -8. So that is our answer for part B. For part C, it's pretty straightforward from there because we have everything that we need. C says find the vertex. Well, the vertex, remember, is made up of the axis of symmetry and either our max or min value. So our vertex is going to be -3, -8. There we go. Okay. And that's our answer for part C. For part D, it says to graph the parabola now. So I'm going to go ahead and come up here and graph this parabola. Let me get my ruler. And this is going to be kind of a gross... Oh, I think I did this wrong. I did. Uh-oh. Shame on me. Shame on me. -18 plus 36 is +18. Minus 10 is +8. So my vertex is -3, +8. All right, well, with that said, whenever we graph a parabola, I'm not going to give you something too crazy extreme. Basically, you should be able to fit most of the parabola within a -10 to 10 window, meaning that if you start back -10 and move forward +10, you start down -10 and move up to +10 in your coordinate plane, you should get all the points that you need. So I'm going to go ahead and graph that size graph here. A little bit short, but that's okay. All right. All right, so there's my big graph there. And remember that this is y and this is x. We're going to go ahead and plot our vertex now. Remember, our vertex was -3, 8. So that means we're going to go back 3, 2, 3, and up 8. 1, 2, 3, 4, 5, 6, 7, 8. And we're going to put our point. So that's that. Then what do we need? Well, we need our slope pattern. What is our normal slope pattern? Our normal slope pattern, remember, is 1 over 1, 4 over 2, 9 over 3. And what do we do with that? Well, we take that and we multiply it by our a value. Back in the original problem, it said that a was -2. So we're going to go ahead and multiply all of these by -2. So remember, when we multiply, it's -2 over 1. So we can get fractions. And we end up with -2 over 1, -8 over 2, and -18 over 3. And so that's the slopes that we follow. From the vertex, we go down 2 and over 1. From the vertex, we go down 8 and over 2. And then we go down 18 from the vertex. So 10, 12, 14, 16, 18, and over 3. All right. Then we're going to go ahead and reflect that about the axis of symmetry. Remember, we found the axis of symmetry to be -3. So we're going to go ahead and draw that dotted line for the axis of symmetry just so we can see it a little bit better. Okay. And then we're going to reflect all the points over. So since that's 1 away, we'll go 1 away on this side. Since that's 2 away, we'll go 2 away on this side. And then since this one down here is 3 away, we'll go 3 away on that side. And therefore, we have our parabola. And again, it's not about how perfect your parabola looks. What is important is that you identify your key points, okay? Now, that is our graph. That's great. That was part D. Part E, let's see here. Zoom out here so you can see that graph as a whole. Part E said, what is the domain and the range? Well, the domain here, because this is a parabola that keeps on going forever, we're going to go back forever and to the right forever. This parabola keeps going to the left as we go further and further down here. It keeps going to the left. So we would say from negative infinity, less than x, and then as on this side, as the parabola goes down, it keeps going to the right. So that goes off to infinity there. Negative infinity back, positive infinity forward. So that's our domain. Okay. Then for our range, well, the range, remember, is the lowest point to the highest point. So what's the lowest point here? The lowest point is negative infinity. Negative infinity is not really a point, but it's an idea that this keeps going down forever and ever and ever. So negative infinity, less than, remember, y, because we're talking about range. What's the highest point? The highest point is 2, 4, 6, 8. Oh, look at that. It was our maximum value. We already knew the highest point. We did that back in part B. And then we're going to put less than or equal to, because the parabola does touch the y value of 8. So that is our answer for E. For F, it's asking for the interval of increase and decrease. So when is this graph increasing? Well, it's increasing which half of the parabola? On the left side or the right side do we see this parabola going up? On the left side we see it going up. So from negative infinity, less than x, less than or equal to negative 3. Remember, when we're identifying increasing values or decreasing values, they're always the x values. So we go from negative infinity all the way to the axis of symmetry where we see it stop going uphill. For decreasing, where do we see it decrease? We see it decrease on this side of the parabola. Where does it start decreasing? It starts decreasing at this point, not the y value, the x value. The x value is negative 3, less than or equal to x, less than infinity. So we start at negative 3 and we continue downward for as long as we go to the right. So that's our increase and decrease intervals. All right, G is going back to a concept that a lot of us struggle on, average slope. Remember, average slope, the way to find slope is y2 minus y1 over x2 minus x1. So if I can find those coordinates, then I can graph or I can identify the slope. Now the interval that it gave me was negative 5 to negative 2. Negative 5, come on, negative 5 to negative 2. Well, what does that mean? That means x1 is negative 5 and x2 is negative 2. Right? These are both x values. This is an interval, x1 to x2. Now let's find our y values. Well, if I go back to 5, 1, 2, 3, 4, 5, where do I have to go to get on the graph? Well, I don't have to go up or down at all. The point is on the x-intercept there. So we can say that the coordinate here is negative 5, 0. And then the other point is at x equals negative 2. So if I go back 2, where do I have to go to find the y value? Well, I have to go up to this point. That's on the parabola. Back 2, what is that coordinate? It's 1, 2, 3, 4, 5, 6. So it's negative 2, 6. So there's our two coordinates. Now we would just take those and plug it into our slope formula, or we could count the rise and the run. I'm going to go ahead and plug it into our slope formula. y2 here is 6, y1 is 0, x2 is negative 2, and x1 is negative 5. And that simplifies to 6 minus 0 is 6. Negative 2 minus negative 5 turns into negative 2 plus 5, which is 3. And then that simplifies to 2. So my average slope is 2 here. Now we can check that. we can say to go from here to here, I went up 1, 2, 3, 4, 5, 6, and over 1, 2, 3. I went up 6 and over 3, exactly what I have here, and that reduces to 2. Okay? So that is my average slope. And then the last problem, last thing it's asking for is my x and y intercepts. So my x-intercepts are where the parabola crosses the x-axis. We already identified one here. The other x-intercept is right there. So our answers are -5, 0, and -1, 0. So that is my x-intercepts. And then my y-intercept is where the graph crosses the y-axis. Well, where do we see that? We see that right here. And this is kind of one of the main points of this lesson. What is this y-intercept? Well, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 down. So that coordinate is 0, -10. That is my y-intercept. Now, what I want you to see, though, my y-intercept is -10. I actually can find that in my function. Where do I see my y-intercept, or at least the y value? I see it at the very end. That c value, ax squared plus bx plus c, is always going to be your y-intercept if the function is written in standard form. So you can identify a point on the parabola instantly by just looking at standard form. You can see your y-intercept. It's 0, -10. All right, so that wraps up the lesson for today, talking about graphing parabolas from standard form. Remember, the first thing you have to do is identify the axis of symmetry using that fancy formula, -b/2a. And then from there, you plug that into the function to find the y value. And then those two values, the x and the y, make up your vertex. Then you can follow your slope pattern and graph from there. I hope you understood this lesson. If you have any questions, please comment below or reach out to me so I can help you out. Have a great evening.